Why rust is more dangerous than it looks. It starts as a stain, a faint orange bloom spreading across silent metal. But that color is not decay. It is chemistry announcing that something irreversible has begun. Rust feels slow, almost harmless, a surface problem, an aesthetic flaw. Yet rust is one of the most destructive chemical processes humans face. It weakens bridges, cripples ships, collapses buildings, and erases infrastructure. Every year, it costs civilizations trillions, and it does so quietly. To understand why rust matters today, we need to rethink what it is. Rust is not metal aging. It is metal reacting. Specifically, iron surrendering electrons to its environment. This reaction has existed longer than cities, longer than tools, longer than humans themselves. And modern society now depends on resisting it constantly. Steel holds up cities. Iron frames carry roads, rails, towers, and machines. The modern world stands on metals that want to return to ore. Rust is that return, a reversal of refinement. And the chemistry never forgets the original state. At first, iron seems stable, solid, strong, predictable. But introduce oxygen and water and everything changes. Electrons begin to migrate. Iron atoms lose control of their structure. What was once order becomes fractured. The surface transforms first. Then depth follows. This is the first narrative beat. Exposure. Bare metal meets air and moisture. Oxygen molecules pull electrons from iron atoms. Water acts as a conduit. The reaction begins without noise or heat. No warning. No delay. The second beat follows invisibly. As iron oxidizes, it expands. Rust occupies more space than the metal it replaces. This expansion creates stress. Cracks form. Protective layers split open. Fresh iron is exposed. The reaction accelerates. Then comes a third beat. Rust does not protect the metal beneath it. Unlike some oxides, it flakes and crumbles. Each layer that forms peels away, revealing new surface, inviting more reaction. The chemistry feeds itself. From the outside, nothing dramatic appears to happen, but strength is already draining away. Load-bearing capacity drops. Fatigue resistance weakens. Metal that once held tons now struggles under its own weight. And this is where the story begins to darken. Because rust does not announce when it becomes dangerous. It hides behind paint, behind concrete, behind assumptions of permanence. And by the time it is visible, chemistry has already taken far more than it shows. Rust advances without urgency. It does not need speed. Time is enough. Once the initial oxidation begins, the environment takes over. Humidity supplies water. Air supplies oxygen. Salts increase conductivity. The reaction becomes easier with every cycle. Metal corrosion turns from possibility into certainty. At first, engineers try to stop at the surface. Paint blocks oxygen. Coatings isolate moisture. Galvanization sacrifices zinc instead of iron. These strategies work for a while, but they only delay the chemistry. They do not erase it. Here is where the story deepens. Because rust is not uniform. It attacks weaknesses. Scratches, weld seams, bolted joints, any place where protective layers thin. Corrosion concentrates stress, exactly where strength is needed most. Failure begins at the margins. Inside large structures, rust changes behavior. Confined spaces trap moisture. Temperature cycles condense water repeatedly. Oxygen diffuses slowly but persistently. The reaction becomes rhythmic. Each cycle removes more metal. Each pause sets the stage for the next attack. The chemistry also changes form. Different iron oxides form under different conditions. Some expand more. Some conduct electricity better. Some accelerate further corrosion. Rust evolves as it spreads. It adapts to environment. This is the early conflict, because the damage is not proportional to appearance. A beam can look intact while losing most of its integrity. Corrosion hollows from within, leaving shells that collapse suddenly. There is no gradual warning for those who rely on strength. History is filled with these moments. Bridges failing decades earlier than predicted. Ships splitting at sea. Pipelines rupturing underground. Each failure traced back to corrosion that went unnoticed. Chemistry outpaces inspection. Modern infrastructure magnifies the risk. Structures are larger, loads are heavier, margins are thinner. The same rust reaction now carries higher consequences. What once damaged tools now threaten systems. And yet, rust remains underestimated because it works slowly, because it looks familiar, because it feels manageable, until the chemistry crosses a point where intervention no longer matters. This is where rust reveals its true danger, not as surface decay, but as a structural betrayal. As corrosion progresses, metal loses more than mass. It loses continuity. Iron atoms that once shared electrons in rigid lattices become isolated. Stress no longer distributes evenly. It concentrates. Tiny flaws become fault lines. Under load, those lines propagate silently. This is the heart of the conflict, because metal is trusted to behave predictably. Engineers calculate strength assuming uniform material. Rust destroys that assumption. It introduces randomness into systems built on precision. The structure still stands, until suddenly it does not. Fatigue accelerates the damage. Every vibration, every temperature shift, every passing load flexes weakened regions. Cracks grow incrementally, not visibly, not audibly, but relentlessly. The chemistry has already done its work. Physics simply finishes the job. Inside reinforced concrete, the danger multiplies. Steel rebar corrodes beneath the surface. As rust expands, it fractures concrete from within. Cracks appear long after corrosion begins. By the time they are visible, internal damage is extensive. The structure is compromised before anyone suspects. This creates a cruel illusion of safety, because systems rarely fail where rust is obvious. They fail where corrosion is hidden, behind walls, below ground, inside sealed compartments. The strongest-looking structures often carry the weakest cores. Maintenance fights a losing battle. Inspection relies on visibility. Chemistry exploits invisibility. Even advanced sensors struggle to track internal corrosion accurately. By the time intervention occurs, options are limited. Replace sections, reinforce, or accept reduced lifespan. The buildup becomes undeniable here. Rust is not just removing metal. It is eroding confidence. Design lifetimes shorten. Safety margins shrink. Costs multiply. Entire infrastructures age faster than planned. And the paradox deepens. The more we rely on metal, the more rust matters. Urban density increases load. Climate change increases humidity and salinity. Coastal expansion exposes steel to harsher conditions. The chemistry grows more aggressive as society grows more dependent. Rust does not need a dramatic event to win. It only needs time, and time is always available. While humans plan in decades, chemistry works continuously. Every second adds up. Every reaction moves forward until strength exists only on paper. This is the moment tension peaks. Because the question is no longer how rust forms. It is whether control is ever truly possible. And that realization sets the stage for the final reckoning. The climax is not collapse. It is recognition. Rust is not a flaw in metal. It is metal obeying chemistry. Iron was extracted from or using energy. Rust is that energy being reclaimed by the environment. The reaction is not malicious. It is inevitable. Once this is understood, everything shifts. Prevention is no longer about stopping rust. It is about managing it, controlling exposure, limiting moisture, interrupting electrical pathways, designing structures that expect corrosion, not deny it. The resolution lies in humility. Civilizations rise on materials they do not fully control. Steel feels permanent, but permanence is an illusion created by maintenance. Left alone, metal always returns to nature. Rust is a reminder. Modern relevance makes this unavoidable. Aging bridges, expanding cities, changing climates. The chemistry is accelerating while infrastructure ages. Ignoring rust is no longer an option. It is a safety decision. This understanding reframes responsibility. Inspection is chemistry awareness. Maintenance is reaction management. Design is an agreement with physics. When these align, structures endure. When they do not, failure is only a matter of time. Rust is dangerous not because it destroys metal, but because it destroys certainty. It removes predictability from systems that demand it, and once predictability is gone, trust collapses soon after. Seeing rust clearly changes how the world looks. Every being becomes temporary. Every structure becomes a process, not a product, held together by vigilance, not permanence. Sometimes the smallest shift in perspective becomes the beginning of a new future. Why